Bismillahirrahmanirrahim. Quote of the day. Once you replace negative thoughts with positive ones, you will start having positive results. Today, the topic I'll be presenting is surveillance of drinking water under kind supervision of my honorable and kind supervisor, Dr. Saira Afzal. Learning outlines, introduction, national drinking water policy, WHO guidelines for drinking water quality, surveillance of drinking water quality, recent advances, and MCQs. Learning outcomes. At the end of the presentation, participants will be able to describe the guidelines and surveillance of drinking water quality. Water and health. Basically, there are two types of issues: quality and quantity, water pollution and water scarcity. In Pakistan, 50% of diseases and 40% of deaths occur due to poor drinking water quality. Diarrhea, a waterborne disease, is reported one of the leading cause of death in children. SDGs target 6.1 by 2030 achieve universal and equitable access to safe and affordable drinking water for all. Indicator proportion of pollution using safely managed drinking water services. National drinking water policy. In line with National Environmental Policy and Vision 2030 objective is one of the objective is providing access to safe and sustainable drinking water supply to the entire population of Pakistan by 2025. Guidelines for drinking water quality by WHO. The WHO published guideline for drinking water quality. Its implementation ensures safety of drinking water supplies. Guidelines for drinking water quality recommended by WHO 2011 relate to acceptability aspects, microbiological aspects, chemical aspects, and radiological aspects. Acceptability, basically we have to check out the physical parameters, and inorganic constituents are also a part of this. Physical parameters include turbidity. First, drinking water should be free from turbidity, interferes with disinfection and microbiological determination. Acceptable level turbidity of less than 4 NTU measured with turbidity meter. Here's a picture showing a range of low turbidity to higher turbidity. Color. Drinking water should be free from color, organic matter, iron, manganese, industrial waste, etc. The guideline value is 15 true color units. Taste and odor developed due to contamination by chemical storage and distribution, indicative of pollution or malfunction during water treatment or distribution. Temperature. Low water temperature decrease the efficiency of treatment process. High water temperature enhances the taste, odor, corrosion problem may increase. No guideline value is recommended. Inorganic constituents, chlorides. All water includes rainwater contain chlorides. Standard level for chloride is 200 milligram per liter. Maximum permissible level is 600 milligram per liter measured by spectrophotometer or titration method. So spectrophotometer, here's a picture of that. Hardness. Taste threshold for calcium ion is 100 to 300 milligram per liter. Excessive soap consumption and scum formation forms deposits of calcium carbonate scale on heating. Soft water, low buffer capacity, corrosive for water pipes, measured by titration method. Ammonia. Ammonia originates from metabolic, agricultural, industrial processes and from disinfection with chloramine. Natural levels are below 0.2 milligram per liter. Anaerobic groundwater contains 3 milligram per liter. Its presence indicates pollution by bacteria, sewage, or animal waste. pH less than 7 causes severe corrosion. Acceptability range is 6.5 to 8.5 measured with pH meter. Hydrogen sulfide acceptable limits 0.05 to 0.1 milligram per liter given rotten egg odor, stagnant water. Iron on exposure to atmosphere, ferrous iron oxidizes to ferric iron, gives a reddish brown color to water, deposits slimy coating on pipes. Sodium measured with flame photometer, average taste threshold for sodium is 200 milligram per liter. Here's a flame photometer. TDS, total dissolved solids, important effect on taste of water. Acceptability levels of TDS is less than 1000 milligram per liter. Excessive levels cause scaling of boilers, pipes. Zinc gives undesirable astringent taste. Zinc content is more than 5 milligram per liter, gives opalescent look and greasy film on boiling. Manganese, acceptable level is less than 0.1 milligram per liter. Excess manganese stains sanitary ware and laundry. Copper increases corrosion of steel fittings. Concentration is more than 1 milligram per liter, causing staining of laundry and sanitary ware. Aluminium concentration is more than 0.2 milligram per liter, leads to a deposition aluminium hydroxide rock. Microbiological aspects, bacteriological indicators, virological indicators, and biological aspects. Bacteriological aspects, coliform organisms presence in human intestine. Presence indicates fecal contamination. Fecal streptococci occurs in feces, confirmatory evidence of recent fecal contamination. Clostridium perfringens resist chlorination. Presence suggests fecal contamination. Coliforms have two groups, fecal groups, E. coli, non-fecal Klebsiella or aerogens. Why coliforms? Coliforms are abundant in intestine, 200 to 400 billion per day. Easily detected by culture, survive longer than other pathogens, great resistance to force of natural purification. Bacteriological quantity of drinking water organisms. All water intended for drinking guideline values must not be detectable in any 100 ml sample. Treated water entering distribution system, E. coli, total coliform count must not be detected in any 100 ml sample. Treated water entering a distribution system, E. coli, total coliform count must not be detectable in any 100 ml sample. In case of large supplies, must not be present 95% of samples taken through any 12-month period. Virological aspects: free from virus, disinfect with 0.5 milligram per milliliter of free chlorine, residual after contact period of at least 30 minutes at pH 8. Other needs 0.2 milligram per ml criteria. Ozone 0.2 to 0.4 milligram per milliliter for 4 minutes. Biological aspects: protozoa, E. histolytica, Blantidium coli, helminths, infective forms of groundwater, hook forms, schistosomes, free livings, fungi, algae interfere with water treatment. Chemical aspects: inorganic constituents, organic constituents. Inorganic constituents, there is a list of these inorganic constituents and the guideline values are also in front of them. Fluorosis, excess fluoride in the body above 0.2 parts per million. In India have groundwater that is rich in fluoride. So that can lead to dental fluorosis. Organic constituents, here is a list of them, and the upper limit of the consideration is also mentioned in front of it. pH guidelines, pH and turbidity restriction on coal tar based lining in storage tanks. Source of contamination should be identified. The main source of pH, that is polynuclear aromatic hydrocarbons contamination in drinking water, is usually the coal tar containing of drinking water distribution pipes used to protect the pipes from corrosion. These are also formed during some methods of food preparation such as charcoal boiling, grilling, roasting, frying, and or baking. Radiological aspects: radioactivity should be as low as possible. Guideline values: gross alpha activity 0.5 becquerel per liter, gross beta activity 1.0 becquerel per liter. 1 becquerel is equal to 1 disintegration per second. Surveillance of drinking water quality. A water quality surveillance and response system, SRS, is a framework designed to support monitoring and management of distribution system water quality. The system is comprised of one or more components that enhance a drinking water utilities capability to quick detect and respond to water quality issues. It's defined as the continuous and vigilant public health assessment and overview of the safety and acceptability of drinking water supplies, according to WHO 1976. Service indicators: quality, quantity, accessibility, affordability, continuity of drinking water supplies. Objectives of surveillance: identify and evaluate factors associated with drinking water which could pose a health risk, to take both preventive and remedial action for development of rational strategies for improvement of quality of water supply services to meet aggregate national standards and institutional targets. Surveillance approach, it has audit. There are two parts: audit approach and the direct assessment. Audit approach compromise of the information regarding system performance and review records to ensure data is reliable. Activities in surveillance function: approval of a new sources, including private-owned watershed protection, approval, construction, and operating procedures of water works, disinfection of the plant and distribution system, periodic flushing programs and cleaning of water storage facilities, certification of operators, regulation of chemical substances, cross-connection control, backflow prevention, leak detection control. Sanitary surveys, monitoring programs, development of codes of practice for well construction, pump installation, and plumbing inspection, quality control in bottled waters. Element of surveillance program: sanitary surveys, sampling, bacteriological surveillance, consisting of 3 parts, that is presumptive coliform test, multiple tube method, membrane filtration technique. Second is detection of fecal streptococci and Clostridium perfringens. Third is the colonicon, biological examination, and chemical surveillance. A sanitary survey is defined as an on-site inspection and evaluation by a qualified person of all the conditions, devices, and practices in the water supply system which pose a danger to the health and well-being of water consumer. A new source is being contemplated. Laboratory analysis indicates hazard to health. An outbreak occurs to interpret bacteriological, chemical, and physical analysis of samples when any change takes place that can affect the water system. For example, industries coming up in water shed and General guidelines for sampling. Ensure no external ensure no external contamination. Asepsis glass bottles which securely fitting stoppers or caps with no toxic liners. Sample for general analysis is equal to 2 liters non-acidified. Bacteriological analysis is equal to 250 ml sterilized bottle. Metal analysis is equal to 1000 ml acidified sample. General guidelines for sampling: rinse simple container 3 times with the sample before it is filled. Leave small air space in the bottle. Allow mixing of sample at the time of analysis. Label the sample. The sample code and the sampling data should be clearly marked on the sample container or the tag. Complete the simple sample identification for each sample. The sample identification from a form should be filled for each sampling. Sample identification form should all be kept in a master file at the laboratory where the sample is analyzed. Winchester quart bottles for the physical and chemical examination. Sampling done by a sampling assistant. So here are the bottles being used. 2 basic types of sources for sampling: water from a tap in a distribution system, water from watercourse, river, lake, well, etc. Sampling techniques. Here are the sampling techniques that are mentioned. Sampling from reservoir, transport and storage of sample, date, time of collection, dispatch, source, rainfall findings. Third is the bacteriological surveillance. A complete bacteriological examination consists of 3 tests: presumptive coliform test, the detection of the fecal streptococci and Clostridium perfringens. Third is the colony count. A presumptive coliform test, a multiple tube method, confirmatory test, and the membrane filtration technique. The presumptive coliform test, here's a picture showing the presumptive coliform test being performed. And for confirmed test, take the positive tube for the presumptive test, incubate one plate at 37 degrees centigrade for 24 hours, and another at 44.5 degrees centigrade for 24 hours. Look for atypical colonies in the media. Blue, black with green metallic sheen colonies are of E. coli. Membrane filtration technique: lactose, tegretol, agar, membrane, lauryl sulfate lactose. Colony count, the nutrient agar at 37 degrees centigrade and 22 degrees centigrade, an estimate of the general bacterial purity of water. Same source of frequent intervals may be of considerable value. A sudden increase in the colony count may give the earliest indication of contamination. Water at the point of consumption, disinfected, non-disinfected. Not disinfected plate count after 2 days at 37 degrees centigrade is 0. And for non-disinfected, it's 10. Plate count after 3 days at 22 degrees centigrade is 20. And for not disinfected is 100. Fourth is the biological examination. Water may contain microscopic organisms such as algae, fungi, yeast, protozoa, rotifers, the crustaceans, the minute worms, etc. These organisms are collectively called plankton. These produce odor and objectionable taste in water. They are index of pollution. The degree of pollution is assessed qualitatively and quantitatively by the number of organisms prevailing in the water. Fifth is the chemical surveillance. Chemical surveillance of drinking water is assuming greater importance in view of industrial and agricultural pollutants into raw water source. Test for pH, color, turbidity, chlorides, ammonia, chlorine, demand, and residual chlorine are basic tests. Complete chemical analysis include analysis for toxic metals, pesticides, organic chemicals, and radioactivity. Recent updates. The recent advances, future trends, applications, and challenges of Internet of Underwater Things, a comprehensive review. The abstract shows oceans cover more than 70% of the Earth's surface for various reasons. Almost 95% of these reasons areas remained unexplored. Underwater wireless communication has widespread application, including real-time aquatic data collection, naval surveillance, natural disaster prevention, archaeological expeditions, oil and gas exploration, shipwreck exploration, and the monitoring of aquatic species and water contamination. The promising concept of the Internet of Underwater Thing is having a great influence in several areas, for example, in small research facilities and average-sized harbors, as well as in huge unexplored area of ocean. The Internet of Underwater Things, IoT, has emerged as an innovative technology with the potential to develop a smart ocean. The IoT framework integrates different underwater communication techniques such as optical, magnetic induction, and acoustic signals. It is capable of revolutionizing industrial projects, scientific research, and business. The key enabler technology for the IoT is the underwater wireless sensor work. However, at the present, this is characterized by limitation in reliability, long propagation, delays, high energy consumption, dynamic topology, and limited bandwidth. The study examines the literature to identify potential challenges and risk as well as mitigating solutions associated with the IoT. Our findings reveal that the key contribution elements to the challenges facing the IoT are underwater communications, energy storage, latency mobility, a lack of standardization, transmission media, transmission range, and energy constraints. Furthermore, we discussed several IoT applications with highlighting potential future research directions. And a challenge is Pakistan is facing a challenge, and estimated 70% of households still drink bacterially contaminated water. 53,000 Pakistan children under 5 die annually from diarrhea due to poor water and sanitation. Pakistan has made significant progress in improving access to sanitary, yet 25 million people still practice open defecation. Lack of access to proper sanitation facilities impact negatively the health and well-being of the children. WaterAid in Pakistan Web carries forward its global organization mission of ensuring universal access to safe water, sanitation, and hygiene, which since 2014 has been to reach everyone, everywhere by 2030. Time for MCQs. MCQ number 1: in a village, ABC people used to bring water from canal near the industrial area for the daily use. If domestic water has a color and a specific taste, it can be classified as A, non-contaminated water, B, clean water, C, filtered water, D, wholesome water, E, potable water. Anyone? It's C, polluted water. Research team in our awareness program regarding clean drinking water shared the information that source of water which can be ingested without any prior treatment of purification is A, rainwater, B, wells, C, surface water, D, groundwater, E, none. It's D, groundwater. A researcher with his team has visited the area with an epidemic of gastroenteritis. Sampling for drinking water was taken and sent for examination. The organism responsible for water pollution and this epidemic would be A, streptococci, B, E. coli, C, salmonella, D, SARS virus, E, Ebola virus.
C.
No, it's B, E. coli, which is the major cause of epidemics. It's a fecal bacteria, and that mainly cause the gastroenteritis or dysentery. A researcher has visited the area and took the samples of water from different sources of water to check the presence of fecal coliform bacteria. The fecal coliform count would be maximum in A, sludge, B, sewage, C, non-contaminated water, D, inadequately treated water, E, inadequately treated water.
A.
No, it's B, sewage. A researcher has visited the area ABC and collected the water sample for bacteriological examination of water and it sent it to the lab. The amount of sample required for examination is A, 250 ml, B, 350 ml, C, 450 ml, D, 550 ml, E, 150 ml. Anyone? As I mentioned earlier in the slide, the different sampling sizes. So here it would be A, 250 ml. Yeah, it's A, 250 ml. A researcher has visited village ABC and observed that the mostly youngsters of community, especially children, had staining and pitting of the teeth. Of teeth. The condition is observed by ingestion of water which has high content of A, aluminium, B, zinc, C, fluoride, D, mercury, E, iron.
Fluoride.
Yes, it's fluoride, which is causing fluorosis. Seventh is a researcher has visited the area and collected the water sample to check the quality of water. Regarding transportation of water sample to the lab, most important information to be accompanied is A, geological information of soil, B, any suspected source of pollution, C, data, place, and time of dispatching the sample, D, source of water, E, no information needed.
C.
Yes, at C, we have to write the data, place, and time of dispatching the sample. Eighth is a researcher has visited the area and collected the sample of water as there is suspicion for the fecal contamination. Confirmatory test for detection of fecal E. coli is in water sample is A, multiple tube test, B, incubation at 44.5 degree Celsius, C, colony count, D, plate count, and E, incubation at 20 degrees Celsius.
Colony count.
No, it would be B. I mentioned in the slide there's a confirmatory test and we have to do the incubation at 44.5 degrees centigrade. Ninth, in Karachi, one of the beaches is allocated for various water sports, including surfing, water skiing, and swimming. Most important health risk associated with recreational use of water is A, drowning, B, contamination with sewage, C, exposure to heat and ultraviolet rays, D, soil pollution, E, air pollution.
B.
Yeah, obviously it's B. It's the contamination that is we are more afraid of. 10th, a researcher has visited the area and observed that many people, men and women of the community of the area, have swelling in front of their neck. This commonly seen a non-infectious disease associated with water supplies in Pakistan is A, diarrhea, A, B, methemoglobinemia, C, dental fluorosis, D, goiter, E, anemia.
Goiter.
Yeah, it's
Goiter, D.
goiter. Thank you so much, everyone. Here is the key. Here are the references, and here's the link of the YouTube channel. Kindly please like and subscribe. Thank you so much for listening.